Classification based on type of particles of the dispersed phase, multimolecular, macromolecular, and associated colloids. Depending upon the type of the particles of the dispersed phase, colloids are classified as multimolecular, macromolecular, and associated colloids. First, multimolecular colloids we'll discuss. On dissolution, a large number of atoms or small molecules of a substance aggregate together to form species having size in the colloidal range 1 to 1000 nanometers. The species thus formed are called multimolecular colloids. For example, a gold sol may contain particles of various sizes having many atoms. Sulfur sol consists of particles containing 1000 or more S8 sulfur molecules. Coming to the second one, macromolecular colloids. Macromolecules in suitable solvent form solution in which size of the macromolecules may be in the colloidal range. Only particle size is important here. Such systems are called macromolecular colloids. These colloids are quite stable and resemble true solutions in many respects. Examples of naturally occurring macromolecules are starch, cellulose, proteins, and enzymes. And those of man-made macromolecules are polythene, nylon, polystyrene, synthetic rubber, etc. So simply you can say polymers. Associated colloids are micelles. There are some substances which at low concentrations behave as normal strong electrolytes, but in higher concentration exhibit colloidal behavior due to the formation of aggregates. The aggregated particles thus formed are called micelles. These are also known as associated colloids. The formation of micelles takes place only above a particular temperature called Kraft temperature, your entrance question, and above a particular concentration called critical micelle concentration, again your entrance question. What is CMC? What is Kraft temperature? Like these questions you can expect. On dilution, these colloids revert back to individual ions. Surface active agents such as soaps and synthetic detergents belong to this class. For soaps, the CMC is 10 power minus 4 to 10 power minus 3 moles per liter. You can expect this in a NEET exam. These colloids have both lyophilic parts. Micelles may contain as many as 100 molecules or more. Mechanism of micelle formation. Let us take the complex of soap solutions. Soap is sodium or potassium salt of higher fatty acid and may be represented as RCOONA. Example ratio sodium stearate CH3 CH2 taken 16 COO minus Na plus. This can be asked exam, which is a major component of many bar soaps. When dissolved in water, it dissociates into RCOO minus and Na plus ions. The RCOO minus ions, however, consist of two parts: a long hydrocarbon chain, also called non-polar tail, which is hydrophobic, water repelling, and a polar group COO minus, also called polar ionic head, which is hydrophilic. Simple. Carboxylic part, okay, RCOO minus is there. COO minus part is solvent loving, alkyl part is solvent hating. COO minus is head and alkyl group is tail. You can see here a big compound is given, C17H35COONA, alkyl group, that is hydrophobic, and COO minus group is hydrophilic, clearly mentioned here. Tail and head. You can see stearate ion in water. When you are dropping, all the stearate ions are becoming like the COO minus groups are with water, and all the tail parts are coming close. Okay, and that spring like looking, that is tail part. The RCOO minus ions are therefore present on the surface with their COO minus groups in water, and the hydrocarbon chains are staying away from it and remain at the surface. But at critical micelle concentration, the anions are pulled into the bulk of the solution and aggregate to form a spherical shape with their hydrocarbon chains pointing towards the center of the sphere, with COO minus part remaining outward in the surface of the sphere. An aggregate thus formed is known as ionic micelle. These micelles may contain as many as 100 such ions. You can see here, first one normally putting in water, second one is CMC. They are forming micelle. A and B, it's mentioned here. Coming to this one. Similarly, in case of detergents, example ratio sodium lauryl sulfate CH3CH2 taken 11 SO4 minus Na plus. The polar group is SO4 minus along with the long hydrocarbon chain, and the mechanism of the micelle formation here also is same as that of soaps. Cleansing action of soaps we'll discuss in another video.